In this video, we're going to be beginning to prove Euler's method from the definition of a derivative via secant lines. So we do this from our knowledge that f of a prime, and the reason why we start with f prime of a, not f prime of b or f prime of c, etc., is because we see here that within Euler's method we have a derivative of a. And in general, when you're trying to prove methods or you're trying to prove statements, always try to work towards and in relation with the quantity or theorem that you're trying to prove for. So what is f prime of a's definition via secant lines and limits? Well, that is the same thing as the limit as b approaches to a of f of b minus f of a divided by b minus a. If you are not familiar with this equation, you can check out my previous videos where I explain this concept in more detail and where it comes from. And with this in mind, we can begin to analyze a certain property of this limit. And that is that when b minus a infinitely gets closer and closer to 0, represented by this notation with two less than symbols, it shows us that this limit will be approximately equal to f prime of a. And think about why this is true. If we have a graph, and we have a graph such as this, and let's say that our curve is like this, and this is called f of x, and we have our a variable here, and we have our b variable here. When b infinitely approaches to a, which is present within the limit, it will infinitely approach the derivative of a, but it will never quite get there, because when infinitely gets smaller, it will never quite reach it. So therefore, we will have to say that f prime of a, when b minus a infinitely approaches 0, is approximately f of b minus f of a divided by b minus a. Or in other words, the derivative of a is approximately the secant line between f of b and f of a. So therefore, with this in mind, what we can do is we can cross multiply to get f prime of a times b minus a is the same thing as f of b minus f of a. And with this, we can add f of a on both sides to get f of b is the same thing as f of a plus f prime of a times b minus a. And here we have it, Euler's formula from the definition of the derivative via secant lines. And this is the secant definition for a Euler's method. And in future videos, we'll be applying certain examples that will help us better understand Euler's method more conceptually. But that is the proof of Euler's method.